Well, good morning, all. Today we're starting with Chapter 9 on static electricity. Chapter 10 will be on current electricity, but static electricity is always the place you want to start with. So, first of all, what do we mean by static electricity? A static charge is an electric charge at rest. In other words, it's not moving. Okay? For example, the charge you acquire when you're walking across a carpet, actually, you get a better effect if you shuffle. You shuffle your feet because it's the rubbing that does it, that transfers electrons. I will get to that later. Your feet on carpet is called static charge. Because it is at rest on you until you touch something or someone. Or someone. And at that point, it is rapidly transferred. Okay? Discharge is when the charge is lost. And basically, this is what we're talking about here. The charge is lost, so that's discharge. Now you can do it, as we said, it can happen quite rapidly, but electrons are funny because they're out there, they tend to move around. So if you just don't touch anybody or anything, over time you will lose the charge. Okay? Because it's gradually lost to the air. You guys have probably rubbed a balloon on your shirt or your hair or something and then stuck it on a wall. Well, you'll recall from that experience that the balloon doesn't last there forever. In time, it will gradually drop down the wall. And that's because the electrical difference, the static charge that you developed, the electrons have actually gradually moved from one to the other and they become neutral again. Okay? So static charge lasts longer inside on winter days when the heated air is very dry. Okay? If you have moisture, the static charge tends to flow easier in moisture. As you can well imagine, electricity will travel in water. And the study, the next point is the study of static charge is called electrostatics. Oh. Actually, we're studying this in Physics 12 right now. Don't think we need two words the same. We cannot study electric charge directly. but we can only see the effects. And I invite you, there's a number of different videos in Moodle that I invite you to look at. I'm not making it mandatory, but some are like super fun, especially the one on nine cool things you can do with electrostatics, and there's another one on why gasoline and electrostatics don't mix. So that's weird. That's it. It was not as bad as I thought would happen, but anyway. So Benjamin Franklin. I wish I had a picture that I could show you. If you wanted to look at, use the PowerPoint, you'll get pictures in there, which is nice. But Benjamin Franklin proved that lightning was caused by static charge or static electricity. It turns out that air molecules in the different air is made up of different gases. So the gas molecules and the different particles, as they move up and down in the air column, can create a static charge difference between the ground and the atmosphere. And when that occurs, if the difference gets large enough, then you'll get a discharge, and that's lightning. And lightning has a temperature of like 1 million degrees. So when you hear the thunder is actually the rapid heating and expansion of the air around it. And just like if you have an explosion, a bomb goes off, what you're hearing is the noise, the blast noise, is the compression of the air because of the rapid heating around it. Same thing, the bang in thunder is caused by that same rapid heating of air that surrounds the lightning bolt. The result of his research and that of others and others, it was found that there are two types of charges, positive and negative. And negative. Okay, now it turns out that if you have two objects with the same charge, two objects with the same charge, like, and we refer this as like charges, okay, they'll repel or push away from each other. And the law of electric charges, this was coined by a guy by the name of Charles Dufay. Charles Dufay. This is his deal. The laws of electric charges. Like charges repel, opposite charges attract. I don't like words like that. I like to draw diagrams. So if I was going to draw a diagram, I have this one. Let's say these are both positive, then they're going to repel. Okay? If I have two negative charges, same thing's going to happen. They're going to repel. If I have one that's positive and one that's negative, they're going to attract. And they'll be actually attracted to each other. Okay, so how do you feel about that? Pretty straightforward. I know some of the words were repetitive, but that's okay. The next thing is like, where does the charge come from to begin with? Basically, it all originates with the atoms. And which I page over. There we go. And it turns out that it all depends. Where are you? There. It all depends on how many electrons an atom has. If it has more electrons than protons, it is a negatively charged. Ion. If it has fewer electrons than protons, it has a positive charge. Or it is a positively charged ion. For example, if we go back to the last chapter, the classic ones was if we had sodium, and I think sodium normally has 11 protons, and it has 11 electrons. So by itself, these cancel out, and so the net charge is 0. But remember that sodium likes to give up an electron. So it's not going to change its number of what's the name? It's not going to give up its protons, because then it'd be something different. So what it does do is it does give up electrons. So sodium will still have 11 protons, because that's what makes it sodium, but it loses one. So 11 plus 10 minus is plus 1. So that's why sodium has a plus charge of 1. Okay? Same thing with chlorine. Chlorine, it normally has 17 protons and 17 electrons. So it is normally neutral. But it likes to gain an extra electron. So it still has 17 protons, but now it has 18 electrons. So now it is minus 1. So chlorine will produce a negative ion, sodium a positive ion. Now it turns out that the larger the atom, the farther away the outer electrons are from the nucleus. And so they become very sloppy and easy to remove. And so those outside electrons that are really sloppy and not really tightly tied to the nucleus, they're the ones that are going to be ripped off, and they're going to move between the two materials when you rub them together. Okay? Talking about the electrostatic series, some materials are more likely to gain or to lose electrons. LOSE. not lose electrons. Now I'm just going to grab text. It says see text. And 9.1. Okay. Okay. So here is page 276, and here is, oh boy, that's glary, isn't it? I don't know if I can do much with that. Maybe if I go out a little bit. Not really, you can hardly see that. But this is the electrostatic series. So it turns out that if you rub any two of these together, you'll get a transfer of electrons. And so if you wanted to take the best case scenario, if you look at the bottom here, it says rabbit fur, and here's plastic wrap. If you rub plastic wrap and rabbit fur together, what you're going to get is you're going to get a real static charge really fast. And the one that's going to pick up the electrons is going to be the plastic wrap. The rabbit fur is still going to pick up a charge, but he's going to have less electrons. So basically, the electrons are going from the rabbit fur to the plastic wrap. Now, if you take two that are in the middle, like lucite and wood, you're still going to get electrons going from the wood to the lucite, but the difference is so small that you could be rubbing for a really, really long time and you won't get the same effect. So if you're going to do this, pick things that are far apart. Now, what I'd like you to do today is when you finish this, take this table, or take your table, it also lives in Moodle, and see if you can find different things in your household and try to produce static differences, okay? And just for the heck of it. This is fun stuff, eh? It's fun stuff, hey? Alright, so we're almost done. So, we did the example on here. Plaster wrap and wool are rubbed together. The wrap, which is at the top of the wrap is at the top of the list. It's going to gain electrons. From the wool. So any item in the electrostatic series above another will gain electrons. And the idea here is where the electrons come from. The one below loses electrons. Okay? So I think that's pretty much it for what I want to talk about today. But there is some homework involved. Page 277 and 278 of your in your text, and again your text is there, and there is a text material if you wanted to read through, that would be helpful. And so this is due. So once you finish this, take a picture of the whole thing, and then text it at me, text it to me. My cell number is in Moodle there, if you don't already have it in your phone, which by now I think you should have. And yeah, watch the videos, have some fun with this. This is the most fun ever. Okay, so love you, go away, and I will see you next time. Bye now.